Question 3. Feel free to pause the video and work away with this, and you can always pick it up later, or you can fast forward a bit to see the marking scheme and avoid listening to me talking. I'm going to go through this bit by bit just for the guys that want to see it. So we have a smooth sphere A of mass m moving with a speed of u, and it collides with an identical smooth sphere B which is at rest. So their masses are the same. The direction of motion of A before impact makes an angle of 30 degrees with the line of centre of impact. So with the 30 degrees and the u value, I can work out the I and j component of sphere A before impact. And it'll be u cos 30 degrees plus u sine 30 degrees in the I and j direction respectively. After impact, the direction of A makes an angle of theta with the line of centres, where theta is between 0 and 90. The coefficient of restitution is E, and the next part is important. The speeds of A and B immediately after impact are equal. We'll need to use that. Find theta, find E. So start with your table. So under the first column, we know that the speed of A beforehand is u cos 30 in the I direction and u sine 30 in the j direction. B is at rest, so it's 0y plus 0j. Second column, masses are equal, and third column, because the line joining the centres is in the horizontal direction, the I component changes but the j stays the same. So we get vi, or v1i, plus the u sine 30j. And then for b, it's going to be v2i plus 0j. So basically what happens is this collides, sphere A goes towards the top right hand corner direction, and b will travel horizontally across. Right, the direction that changes is the I direction. We put the I components into the two equations. Solve the two equations and we get v1 and v2. Now what I would do here is I would rewrite the velocity of sphere A and B after the collision with the v1 and the v2 subbed in. And we know their speeds are equal, so what you want to do is get the speed of A after impact, the speed of B after impact, all in terms of u and e, and let them equal to each other. So there's the values after impact. There we have on the first line of the thing that just popped up, we've squared both sides, so you get v1 squared plus u sine 30 squared is equal to v2 squared. Sub in the values for v1 and v2 and solve, and you get an e value. So we actually get the e value first here. Now we're looking to find the value for theta. So we know what v1 is, and if we sub in e is equal to a third, that simplifies the value. We know that u sine 30 is equal to u over 2, and then to get the value for theta, we can get the tan of theta, which is the j component over the I component. And then it's just a case of simplifying it. So tan theta was u sine 30, so that's u over 2, all over v1, and v1 worked out as u by root 3, all multiplied by 1 plus e, and then all divided by 4. You're dividing by a fraction, flip it upside down and multiply by it, and tan theta works out as root 3, so theta works out as 60 degrees. Okay, here's the fourth question. I'll expect you to do this on your own. You should pause the video, and I'm going to show you the marking scheme, and you can pause the video for the marking scheme also.